Okay, so we are on HackerRank and we are looking for a medium difficulty problem to solve this time. So here we have a bunch of problems. We're going to go to the random number generator and we'll find that, okay, so it's saying we'll pick the first problem here. The first problem is this climbing the leaderboard. Seems like people, almost half the people fail. Okay, so it says Alice is playing an arcade game and wants to climb to the top of the leaderboard and wants to track her ranking. The game uses dense ranking, so its leaderboard works like this. The player with the highest score is ranked number 1. The players who have equal scores receive the same ranking, and the next players receive the immediately following ranking number. So what does that mean? Okay, so it has this link to dense ranking. Let's see what it means. Dense ranking. Items that compare equally receive the same ranking number. The next item receives the immediately following ranking number. Or equivalently, each item's ranking number is 1 plus the number of items ranked above it that are distinct with respect to the ranking order. Thus, if A ranks ahead of B and C, which compare equal, which are both ranked ahead of D, then A gets the ranking of first, B gets the ranking second, joint second, C also gets a joint second, and D gets a ranking number third. Okay, so it's not like D gets a ranking number of fourth, it does get the ranking number third. Okay. So players who have equal scores receive the same ranking number, and the next players receive the immediately following ranking number, as we saw from that last example. So, for example, the 4 players on the leaderboard have high scores of 190, 90, and 80. Then those players will have ranks 1, 2, 2, and 3, respectively. If Alice's scores are 70, 80, and 105, her rankings after each game are 4th, 3rd, and 1st. Okay, 4 players on the leaderboard have high scores of 190, 90, and 80. And those players will have ranks 1, 2, 2, and 3. That makes sense. But now it's saying if Alice's scores are 70, 80, and 105, her rankings after each game are 4th, 3rd, and 1st. So what does that mean? Well, 80 here I suppose was 3rd, and 80 here is again 3rd. 100 was 1st, and here 105 seems to be 1st. Okay, so this is a slightly confusing example, but let's see if we can clear this up. Complete the climbing leaderboard function below, and it should return an integer array where each element res at that index j represents Alice's rank after the jth game. So climbing leaderboard has these parameters: scores, which is an array of integers that represent the leaderboard scores, Alice, which is an array of integers that represent Alice's scores. It should return an array where each element res at j represents Alice's rank after the jth game. Okay, Alice has this. So Alice is an array of integers that represent. So each of Alice's games in this Alice array, I suppose, correspond to the jth games. So j equals 1 would be the first integer, would correspond to the first integer in this array. J equals 2 would correspond to the second integer in this array, and so on. That's what I'm assuming. Input format. The first line contains an integer n, number of players on the leaderboard. The next line contains n space separated integer scores at I. Last line contains m. Okay, I think this input format is mainly given for the command line argument, but yeah, as I thought, we only need to worry about this one function with these parameters. Okay, so here are the constraints. So n is between 1 and 20,000, or sorry, 200,000 inclusive. And same thing with m. So m is the number of games Alice plays, n is the number of players on the leaderboard. Next line means n space separated integer scores at I. M, Alice's game scores. Okay. So 0 to 1 billion is the scores, possible scores. And same thing for Alice's scores. And the index goes from, well, as we know, from 0 to n or m minus 1 inclusive, or m or n exclusive, which is the same thing. The existing leaderboard scores is in descending order. Okay, so this is a little hard to understand. It says that the scores array is in descending order, and then Alice's scores are in ascending order. So I don't know what it's trying to say. I guess they have an example, so that'll clear things up hopefully. But for 60% of the maximum score, this is the constraint we have to satisfy. So for up to 200 players and up to 200 games Alice plays. The output format, we print m integers. The jth integer should indicate Alice's rank after playing the jth game. Okay. Array scores, array Alice. Okay, so Alice's array is generally okay, so there's no correlation between the size of this and the size of Alice's array. So that's probably a good thing to keep in mind. So 7 is the number of scores, number of players in the leaderboard. So 1, 2, 3, 4, 5, 6, 7. And Alice has these 4 games recorded. So as we see here, these are the exact same corresponding values here. So the output is 6, 4, 2, 1. And So let's see why that is. Print m integers. The jth integer should show Alice's rank after playing the jth game. So Alice plays the first game. She gets a score of 5. And we are given a rank of 6. Alice starts playing with 7 players already on the leaderboard, which looks like this. Rank first, second, third, fourth, fifth, and it's 100, 100, 50, 40, 40, 20, 10. After Alice finishes game 0, her score is 5 and her ranking is 6. Her score is 5 and her ranking is 6 because, because of the ranking system we specified beforehand. So this is first, second, third, fourth, fifth, and then anything less than 10 would be sixth. So that's why this is 6th place. But then she gets 25. So now, let's see what happens. Alice is already here. So Alice plays again, or no. So, this time we assume that Alice didn't even play last time, and this is a brand new fresh table, I guess, because Alice, as we can see in this example, has been omitted. So here, what would that give us? Well, Alice has a score of 25, which is between 40 and 20. Well, 40 was 3rd place, 20 used to be 4th place, but now it's going to be 5th place. This 25 is going to be the new 4th place. So 1st, 2nd, 3rd, and then 4th will be 25. Let's confirm. 4th place. And indeed, it does show that Alice will have 4th place. Just one more example. This 50, or actually we only have 2 more, so let's do both examples. 50 is the same as 2nd place, so she'll be tied for 2nd in this case. Is tied with Caroline at 2, as we can see. 120. For this 120, let's see what happens. It's more than anyone else, so she becomes 1st place. And there we go. So we kind of understand how this function behaves. Scores is in descending order. So let's just note that down. Scores is in descending order. And Alice's list goes from j equals 1 to j equals n, or I should say m. Okay, so j equals 1 is her first game, j equals m is her mth or last game, because Alice plays m games according to the specification above. M is the game scores for Alice. M denotes the number of games Alice plays. All right. So how are we going to deal with this? Well, for our solution, we won't really take into account what the runtime is going to be or um, anything like that. We'll just have a solution, and maybe in a later video we can come back to this problem and worry about that. But for now, let's just try to find a solution that works. So let's just remove this, collapse that. Okay. So now, since we know scores is in descending order, we can make actually a new list with no duplicates of that are in scores, because scores carries a lot of duplicates, and those duplicates don't really add much information that we need. So how about we make this new list, scores unique, and we'll say that is equal to scores for now, or we're just going to make a copy of scores, and this scores unique, remember we want to get rid of all the elements that we don't need. So how do we do that? I'm pretty sure there should be a Python built in, but you know what? We can just use a for loop for score in scores unique. All we do now is see if the next score, or actually we'll have to use indices, just remember for I in range len scores unique, what we'll do now is actually, you know what's easier than this? We'll initialize this as a empty array, and now we will iterate through the scores and only add the ones that are unique into this. That's probably a better solution. For score in scores, what we're going to do is if score not in scores unique, then we're going to add it in there. So scores unique dot append, and we're going to append this score only if it's not in the array already. So once again, this can take some runtime, but we are not going to consider the complexity of this. So okay, that should be all right for our purposes of getting unique scores. Now, what we can do is we find each of Alice's scores, and we now remember the indices for this. In index plus 1 equals rank in leaderboard. Okay, so this is a nice relationship we have. The index plus 1 will give us the rank in the leaderboard after we ensure that all these scores are unique. So using this fact, we can see where Alice stands. So we can do I equals 0 while I less than len scores unique, and I plus equals 1. So here what we're going to do is, just while we don't find Alice's score, or we don't find something that's less than Alice's score, we're going to keep track of the index we're at. And that's why we're keeping track of this I value. Okay, so in fact, we're going to have to do that for each of Alice's scores. So for, let's see, for score in Alice, this is what we're going to have to do. I equals 0, while I less than length of scores unique. If so now the condition we need to check is the comparison between Alice's score and the scores unique at that index I. So if scores unique at index I is less, so if it's less than that particular value, or let's say less or equal, then what does that mean? That means we found a score, so less or equal than Alice for score, which is Alice's score. I should probably make that clear, Alice score. So if it's less or equal than Alice score, then what are we going to do? Okay, so here let's write an example. So the scores unique is 21, and Alice's score is going to be, let's say, 32. So Alice's score is 32. Okay, how about the leaderboard looks something like this. The leaderboard goes 30, 40, 50. Alice has scores 23, 1, 33. Alice. This is leaderboard. Then in this case, what happens? Well, we compared 23 to 30. Well, it doesn't meet this condition. Okay, so next index, 23 to 40 doesn't meet this condition. Next index, 50 to 23 still doesn't meet this condition because Alice's score is not greater or equal than 50. And it passes all the way through, and whatever index we have, so whatever index at this point that we have is one less than the rank of Alice in the leaderboard, like we said here. Alice's rank in the leaderboard. So at that point, we once we exit the while loop, we can print I plus 1. That will be Alice's rank in the leaderboard. So, okay, that's case number 1. In another case, let's say it's not right at the end, like in that scenario. So let's say something like 33. And leaderboard actually shouldn't look like this. That was my mistake. But for the sake of 23, that example, since it's less than any of these things here, that shouldn't matter. But let's actually make this look like a proper leaderboard. Because remember, it's in descending order. So now this is a proper leaderboard, because before we weren't in descending order. So good thing we noticed that and we fixed it. Otherwise, this example I'm about to show may not have worked. So this 33 that Alice has, that score is going to be compared to 50, and it will not satisfy this condition because 50 is greater than 33. Same thing with 40, but then we come to this 30 at index 2. So at index 2, we come to 30, and we see that 33 is indeed greater than Alice's score. And you know what? We'll add another test case for, let's say, 40. And we'll test this after just for the equals condition. But right now, let's see the greater equals condition. So Alice is greater equal than 30, which is true. In fact, it's greater, strictly greater. So now what's going to happen is we will print I plus 1, and then we will break so we will break, and just because we don't want it to print this, we'll also have an if statement here. Here we'll initialize a boolean. Found in leaderboard equals false. And in fact, let's not write break. This is the case, and not found in leaderboard. Okay, and if not found in leaderboard, in this case we'll print this, because without this we would be printing twice for the same thing. So we don't want that. That's why we'll have this condition. And of course we need to change this to true here. Once we print this, we'll say, okay, found in leaderboard equals true. All right, so that makes sense. What next? So we went through that 33 example. Now we have 40, which is equal to this. So we have 40 and 40 compared, and it is indeed equal. So it will say, okay, it is the same score. So for that reason, this is going to be this is going to print index plus 1. Oh, you know what? This is not going to work because it can't print index plus 1, unlike last time where it was correct, where we could have printed 33 for this when index is index is 2 and index plus 1 is going to be third place, and 33 should have been third place, so we printed that. But we can't really do the same thing for the equals condition, so we're going to have another if statement. Elif, just copy this stuff. If these scores are the same, so in the case where 40 is the same as 40, if that's the case, then we print I. So this is index 1, and that should be second place. So I plus 1. Huh. For some reason I was thinking that this was not the case. Let me see what prompted me to think that. Okay, so well, let's go back from the top. This 23 or 1 we'll just consider as one unique example since it's smaller than any of these things here. We'll say 23 compared to 50, compared to this, compared to that. Okay, it's in last place here. The index would have been 2, and the index plus 1 would be 3. So actually, it should have printed 4. So in this case, neither of these things would happen, and we would have printed the wrong thing. Here it should be I plus 2. I plus 2. That's what we need. Because it's not here, and in order to be here, it needs to be index plus 1 of this next position. So for that reason, it needs to be index plus 2. Good thing we caught that. Okay, so that's that. And next example, 33, index 0, index 1, and then we finally see that in this if statement, we see that index 33 is indeed greater than Alice's score 33 is indeed greater than this index 2, which is the value 30. So it's going to enter, and in this case it should return 3, print 3, so 1, 2, 3, because it's ranked third. So let's see what it prints. It prints I plus 1, and the I is supposed to be 2. I plus 1 is 3, and indeed third place is 3. Okay, so that's okay. It probably, you know what, even if we removed it here, it's probably nice to treat this equals case separately, just for our own organization, and that's what we'll do. So let's see, now we're at 40, we're at index 0, index 1, and we see that it's equal. So at index 1, it's equal. It should return 2, or print 2, because this is a rank of 2. This would be ranked 2, so it should print 2. But we're at index 1, so we print I plus 1. So if we wanted to, we could have actually kept it less or equal than, but we'll just keep this. See what happens. Okay, and let's run this code. There may be some mistakes. Okay, so it's saying we don't seem to have any output. Okay, let's see if this was our output right here. I think debug output, that might be our output. And the only way to find out is, let's just comment all this out and see if that makes any difference. Comment all this out and run the code. And let's see what the debug output is this time. I wonder if this is what it was talking about. Okay, so the debug output is not given. We'll just print, like 5 or something. Like, let's print 234. Okay, just to confirm that the debug output was indeed our output. Okay, 234. So, okay, so we were almost correct. Let's remove the stuff we just added. Okay, so the only difference was that this expected a 6 and we printed a 7. The rest of the 3 are okay. So 6 and 7, what is going on there? So 5 is being compared to all of these. So this is the case where this thing is smaller than anything else. So if that's the case, then what should happen? Well, it should print. All right, you know what? Let's actually try doing this. 7 is just one more than 6, so whatever we're printing for the case where it's smaller than any of these, we'll just subtract 1. So I plus 1. And in fact, this is actually what we had before, but we reasoned that that was incorrect for some reason. Huh? Okay. This is a little weird. None type is not iterable. So we did print the correct stuff. That's okay, but it's asking us something else. So let's see if it's asking us to return something. Print m integers. So the output is asking us to print m integers. The function, complete the function, it should return an integer array. Okay, so in addition to printing, it also needs to return the array. That's the only thing we needed to do. All right, so here is the array we're going to return, which is going to be climbing leaderboard. We'll just call it Alice climbing leaderboard. and we'll use that to append I plus 1 wherever we see I plus 1. And now we'll try to run this. Oh, we again forgot to return, so still not complete. Almost done. Almost done. Okay, so now we have passed these sample test cases, as we can see, and we'll go ahead and submit it, see what happens with these additional test cases. Fingers crossed, nothing goes wrong, but that's rarely the case, as we just saw. There may be edge cases or something which we may not have considered. Okay, so test case 6 is 6 and 7 are wrong. Okay, 8 is also wrong. And something tells me if 9 follows that pattern, oh wow, so we earned our first star. So all of these have terminated due to timeout. So like we said we weren't going to consider the runtime, but as we can see, the runtime matters a lot here. So maybe we can see how to better solve this using a more reasonable runtime or a better complexity in a later video. But yeah, for now we passed 8 out of the 12 test cases, and hopefully next time we can pass all 12.